Hello everyone. In this video, I am going to discuss Cpget 2023 previous year questions. So in my previous lectures, I have solved some questions. So in this video, I am trying to cover the remaining questions. So the question number 53 is fx equal to mod x plus mod x minus 1. He is asking whether the function f is discontinuous or continuous or differentiable or not differentiable. So in general, whenever these type of function is there, fx equal to mod x minus a. In general, whenever these type of function is there, f is continuous at this point a, but f is not differentiable at point a. So he is asking whether this function is continuous or discontinuous, uh, these points 0 and 1. So in general, if you compare with in general case, here x equal to 0 and x equal to 1. So we have x value 0 and 1. So from this, f is continuous but not differentiable at these points. So we can say that f is continuous but not derivable at 0 comma 1. So this third option is the correct. In general, whenever whatever the point it is in place of a, so we can say that the function is not differentiable at that point a. So the question number 54 is simple integration, that is integration minus 1 to 1 3x square under root of x cube plus 1 dx. So here we have to change the variable x. Just I am considering let x cube plus 1 is equal to some t. I get 3x square into dx is equal to dt. So I am just substituting these values in the given integration values. I get limit minus 1 to 1 and root t into dt. So we have to, I am not going to change the limits here. After doing the integration, I will directly substitute the limit values. So that is here 1 by 2 is there, root 2 means, so we will get 3 by 2 and 3 by 2, limits minus 1 to 1. So here we consider that we are not changing the limits, so we have to substitute the value of t here. So we get x cube plus 1 divided by 3 by 2, limits from minus 1 to 1. So if I substitute the limits, I can get 2 by 3 by 2 minus 1 plus 1 3 by 2. So this simply directly this minus 1 will be goes to 0. So we get 4 by 3. If you substitute the limit here, we get here 3 by 2 is also there. So we get 2 into 2 power 3 by 2. So that gives you 4 root 2 divided by 3. So if you calculate these part, then directly you will get the answer. The second option is correct one for this question. And 55 question is the value of C, Cauchy's mean value theorem for fx equal to e power x and g of x equal to e power minus x in interval a comma b. Here the interval is important. And if you remembering the Cauchy mean value theorem statement, so that is states that whenever f dash of C, he is asking the point C, so I am just taking that point. So this is a general case of that Cauchy's mean value theorem, G dash of C, and that gives f of B minus f of A divided by G of B minus G of A. So by using the given values of function f and g, we just substitute the values here. Here f dash of c means we have to differentiate f with respect to x. We get e power x again because e power x differentiation is e power x. So if you substitute the value of c in place of x, we can get e power c. And similarly denominator g dash of c is we have to differentiate these e power minus x. So in that time we will get e power minus of minus x. So I am just substituting the values. Here we are substituting the x in place of x, we are substituting the c. So we will get e power minus c, and that is equal to f of b means I am just substituting the value of b in place of x. So that is e power b minus, similarly e power a divided by e power minus b, because the function of g value is e power minus x. So and e power minus a. So if you simplify this one, you will get c is equal to a plus b divided by 2. So just take the common of b e power b, and here if you write the inverse of e power minus c, so you will get simply c equal to a plus b by 2. So the question number 56 is, if y is equal to 1 plus x plus x square up to so on for mod x is less than 1, so then what is the value of dy by dx? We know that whenever these type of series is there, we can written as 1 by 1 minus x. So this is, if you write as 1 minus x inverse, so this will give you the value 1 plus x plus x square. It is similar to our given series. So the function value y is equal to 1 by 1 minus x. If you write the binomial expansion like this way, we will get the given series. So here the y value is 1 by 1 minus x. So if you differentiate that y value, we have to differentiate this 1 by, he is asking the dy by dx of y. So we have to differentiate this function of 1 by 1 minus x. So if you differentiate that one, we will get minus 1 by 1 minus x whole square into minus 1, because here minus 1 is there, so we will get minus 1 here. If you calculate that one, you will get 1 minus x whole square. So the third option is the correct option for these questions, simple one. And 57 one is, so the value of c in Lagrange's mean value theorem for the function fx equal to log x on the interval 1 comma e. So similarly our Cauchy, here he was asked that Cauchy mean value theorem. Here he is asking about Lagrange's mean value theorem. If you remembering that statement, so that I will write the Lagrange's mean value theorem statement, that is f dash of c is equal to f of b minus f of a divided by b minus a. So in place of, we already provided fx value, so if just substitute integrate once and substitute the values from the given that statement, so we will get that if you integrate differentiate these fx, so we will get 1 by x, but here c is there, so we just replace the value x as a c, so we get 1 by c, and f of b means log. Here he gave that if the interval a comma b, we use it in general case, so here interval is 1 comma e, so I am just substituting in place of b as a e minus f of a means log 1, so that will give you b minus a means e minus 1. So if you simplify this one, you will get 1 by c is equal to log e means base e is also there, so it will goes to 1 minus log 1 is, we know that 0, and e minus 1 I can written as same. So if you do the cross multiplication, you will get c is equal to e minus 1. So that is the correct option for this question. We get c is equal to e minus 1. So the 58th question is, he is asking again integration, but here he provided that greatest integer of x. So he is asking the integration of x into greatest integer of x. So whenever these type of question is come, we have to write first, we have to break the intervals, that is 0 to 1. We have to breaking the intervals from 0 to 1 into flower bracket x. So that is the greatest integer, and dx plus 1 to 2 x into greatest integer of x dx. So here we don't know what is the value of x, so I am just writing. So in general case, we have to write the greatest integer of x, that is in the value of greatest integer of x, functioning value of greatest integer of x is in between 1 and 0. So whatever the value of x, we will get the greatest integer value is 0 here. So if you take the 0.5, it is goes to clearly 0. So that is the meaning of greatest integer. So we get functioning value 0. Similarly, if you take the greatest integer x in between the interval 1 and 2, so you will get the greatest integer value is 1. So if you substitute these two values in the given breaking integration values, so you will get the integration 0 to 1 x into 0 dx plus integration 1 to 2 x into 1 dx. So if you simply integrate this one, it is goes to 0. So 0 plus integration of x is x square by 2. So if you apply the limits 1 comma 2, you will get 4 minus 1 divided by 2. So that will give you 3 by 2. So that is the correct option. Fourth option is the correct one for these 58th question. So the 59th one is, if function f is in closed interval a comma b to r is bounded function and p1 p2 are two partitions, we are taking the part inside of partitions, so such that p1 is subset of p2, then this is not subset, proper improper subset. So he provided some conditions. So which one is true? He is asking which one is happened, which one is satisfying by using these p1 contains p2 contains p1. So by using these conditions, we have a direct statement. Whenever these type of case arrived, p1 is a contain inside of p2, so always the upper Darboux-Sin sum is greater than or equal to the p1 of upper Darboux-Sin sum is greater than or equal to the lower Darboux-Sin sum of P2. So by using that also, we can say that U of P1F is greater than or equal to U of P2 of F. So that is the correct option for 59th question. So the 16th one is, he is asking the limiting value here. If you apply the limit extends to 0 of e power 3x cos x divided by x. So whenever these type of question come, you just apply first limit. So you will get e power 3x means 1 and cos 0 is 1, and denominator we will get 0. So if you simplify this one, you will get 0 by 0 form. Whenever these type of question come, I already told you in my previous lectures also, whenever 0 by 0 form is arrived, we have to use the L'Hospital's rule. So what is the L'Hospital's rule? We have to use the L'Hospital's rule here. So the L'Hospital's rule is, we have to differentiate the denominator and numerator once. So if I differentiate these numerator and denominator once, so I have that is limit extends to 0, and if I differentiate e power 3x, I can get it 3 into e power x, because the differentiation of e power 3x is 3 into e power 3x, and differentiation of cos x is minus sin x. So we will get minus sin x, and in denominator differentiation of x is 1. So again, if you apply the limit, e power 3x is goes to 1. So we get 3 and minus negative and negative will goes to positive. It will get positive, and sin 0 is 0. So the overall value we will get 3. So fourth option is the correct option for this 16th question. So the 61 is, so for a comma b belongs to the q rational numbers if we provided the operation as a 0 of b, not 0 o of b. This is one binary operation. In place of o, we can use a star also. That is a binary operation. A star b is equal to a plus b by 2. Then the group is q comma some o is satisfy which condition. He is asking which one holds this condition. So that is, he provided group and monoid and semi group, not a semi group. So semi group means, we know that semi group means it should be satisfy the associative condition. Associative condition, if it is satisfy the associative property, we can say that it should be the semi group. So if I take the two elements from the group G, so the associative property is A into B into C is equal to A into B into C. So this is the associative property. We just take by using these binary condition. If you proceed left hand side and right hand side, this is not equal. It will be never equal. So in that time we can say that it is not a semi group. So if you do just apply the condition for these left hand side and right hand side, it will be never equal. So that's why this group is not satisfy the semi group. So 62 question is, if operation star is defined by a star b is equal to a plus b plus 1. So for all a comma b belongs to z, then the inverse of a is, so he is asking the inverse of a. So we know that when we get the inverse, we can say that if suppose I have a two elements from the group G, a comma b is the two elements from group G. So whenever a binary operation b is gives to the identity element, so we can say that b is the inverse of that group. Okay, so here we don't know what is the identity element. Okay, so if suppose if you take the r place in the time, if it is multiplicative inverse means we can take 0 as identity, 1 as a identity. If it is multiplicative, if it is additive means we can take as 0 as the identity. We don't know, he was not provided identity, so we need to find the identity and inverse here. Okay, so what I do, I just take the element for, I am by using the options, we just check one by one whether it is satisfied or not. So he provided that second option is the correct one, we just check it whether it is satisfied or not, only that one. So if I take that option, some binary operation, he is asking the inverse of a, that's why I have written here a, and a star is provided a minus a plus. You have to check each and every option, but I am checking one option, so you should check others whether it is it will be never satisfied, but you can check it. So whenever I write like this way, I will get a star minus a plus 2. So by using these operation, we will get a minus of a plus 2 plus 1. If you simplify this one, you will get a minus a minus 2 plus 1. So that will gives you minus 1. So here the identity element is e. We don't know whether the identity element e is minus 1 or not. So for that, what we do, when we say that that is identity element, a binary operation e and e binary operation a gives you same element, then we say that that element is the identity element. So here we get it, minus 1 is the identity element. So we can do the same operation by using the identity element, whether it is satisfy the identity condition or not. If it is satisfy the identity condition, then we can say that this is the inverse of this group. So I just taking that minus 1 as the identity element, I am checking whether it is satisfy the identity condition or not. So if I take the identity element minus 1, so it will goes to, by using these operation, we will get that a minus 1 plus 1. So we will get a as a, so we will get a. So we can clearly say that minus 1 is the identity, because we are start with a and we will get a. So by using these identity definition, we can say that minus 1 is the identity. So this option is holds. So the other remaining options are wrong. If even if you check the same condition, so this only will be the satisfying for this binary operation. So 63 question is, which one of the following is a subgroup of additive group of integers? This is direct one. We can clearly say that by using that symmetry group also, the set of even permutations is the alternative group. So by that way we can say that option 3 is a, not by that way, we can simply say by using that way also. Even if you want, you can check it that it should be satisfying the two conditions. So of two conditions of subgroup. So 64 question is, let Z be a additive group of integers Cpget and 8Z are subgroups of Z, then what is the value of, he is asking the value of 6 into Z intersection 8 into Z. So whenever these type of questions come, there is a direct statement, the LCM of 6 comma 8 will give you the direct one. So that will give you LCM should be 24 Z. So we can say that directly it is 6Z and 8Z. In that time we will get directly 24Z. Whenever these type of questions ask direct statement, you will just do the LCM, you will definitely get direct answer. And 65 one, the identity element of H, E provided dihedral group here, D4. So means we get that square here. So that is, suppose if you consider A, B, C, D. So he is asking the identity element. When we say that identity element, I already told you in this previous sum. So whenever A star, will give you the same A, then we can say that E is a identity element. Similarly, if you start with A and after that after you are doing the process of rotation or reflection, you will get the same image, means you can say that that process is a identity process. So if you start with our rotation with 360 degrees, so it will goes to, this means 90 degrees, we can say that clearly for this. So if you draw a line like this way, so you will get 90 degrees here, 90 degrees, 90 degrees, every square has a 90 degrees, we can say that. So then only we can call it as a square. So this is 180, 360 degrees, means we can say that that is the identity element directly, because if after doing that rotation process, will the image of that group will go through the same image, then only we can say that that is a identity element. So here that case is happening here. If you start with the rotation 360 degrees, so the symmetric of that whole group will go through the same identity element. Okay, so the fourth option is correct. These r 360 will form a identity element of D4. So 66 question is, so which one of the statement is false? So you make sure that whether he is asking the false or true. So he is asking the false statement. We just go through one by one. So by using H, if H is a subgroup of index 2 in a group G, then H is a normal subgroup of G. Yeah. By using the Lagrange's theorem, we can say that whenever these indexes set of all left cosets goes to index 2, then we can say that that is a normal subgroup of G. So this is also direct statement. U14 will generate the 3 and every cyclic group of prime order. This is false statement. Why? Because if I take a counter example for this, suppose if I take the Z4, it contains the elements 1, 2 and 3. So if I do that, if I do the order of 3, it will produce the order 4. So the order of 3 will produce a 4, then we can say that this group is a cyclic group without prime order.